Hello everyone and welcome back for 9J. I know we're gonna play the product rule today, which is the pretty important rule from the derivative again. So product rule actually means the function notation. If we have two different functions multiply each other, and also your derivative exists, and your function of the derivative will be your first function times the derivative of the second function plus the second function times the first derivative function. Sounds like complicated, and as I rotate with the rotation rules here, please make sure write down this one in your notebook. And here's the proof. I'm not going to go through this one. Please have a look at it if you're interested how to get in the product rule. I don't stop you if you want to prove by yourself again. But for me, it's going to be a long journey. Yep. Let's have a look at the product rule. If we're using the u and v notations, u is a function, v is another function. And your dy dx equal to u times dy dx plus v times du dx. For example, if we got x squared plus 3x times 4x plus 5, and then the functions for fx is x squared plus 3x, and gx will be 4x plus 5, and then f dash x equal to 2x plus 3, and g dash x will become to 4. And then just cross product pretty much. We go do the just multiply each other, and that actually equal to 2x plus 3 times 4x plus 5 plus 4 times x squared plus 3x. And then the rest of just doing the simplify. All right, it's time to do a quick questions. Let y equal to 2x squared plus 1 and 5x cubic plus 16. Cool. All right. The first thing first, we can begin with let u equal to 2x squared plus 1. V equal to 5x cubic plus 16. Perfect. Now, du dx equal to 4x. dv dx equal to 15x squared. All right. I'm going to rewrite the dy dx rule again. dy dx equal to u times dv dx plus v times du dx. And next one, let's start with u equal to 2x squared plus 1, and dv dx is 15x squared. 15x squared. 15x squared plus v is 5x cubic plus 16 and times 4x. And then simplify is 30x quartic plus 15x squared plus 20x quartic and plus 64x. And the question will be 50x quartic. That's the same like term. And then plus 15x squared and plus 64x. That's it. That's the question. And make sure when you do the simplify, make sure you have a like term, okay? Just in case you forgot your like term. And then circle it, highlight it, whatever it is. You can help with that, highlight it, and then you surely will able to know how to do the questions. Okay? Good idea. Let's start with example 2. So if the function and real number for domain but except for 0 is x to the negative 3 and times 10x squared minus 5 to the power of cubic. All right, looks like a very, very hard question, but actually not too bad. Fx equal to fx times gx. Okay, now fx in here is x to the negative 3. And gx equal to 10x squared minus 5 to the cubic. And f dash x equal to negative 3 to the power of negative 4. And g dash x we can actually using the chain rule, so we're gonna do a little bit complicated one. So g dash x equal to something, so we can let u equal to 10x squared minus 5 and du dx equal to 20x, and well, let y equal to u to the power of negative 2 cubic, and dy du equal to 3u squared. So multiply each other, that will be equal to 3 times u, which is 10x squared minus 5 squared times 20x, and that equal to 60x, 10x squared minus 5, minus 5, minus 5 squared. Okay, perfect. All right, then we got that. Oh, that's equal to g dash x. Okay, that looks a little bit tricky, actually. That looks a little bit tricky. So what we're gonna do about it, so we actually can back on this one. So we know fx times g dash x plus gx times f dash x. That's gonna be your f dash x equals. So let's write that one. It's not too bad. X into the power of negative 3 times 60x, 10x minus 5 square. So this one times that one. Okay. And plus the gx, so which is 10x squared minus 5 to the cubic times negative 3x to the negative 4. Okay. Well, we both have the like term, which is, or we say the common factor, and we actually can rewrite as 10x squared minus 5 squared outsider, so it's x to the negative 3 times 60x, and that equal to 60 times x to the power of negative 2, so that equal to 60 times x to the power of negative 2 plus 10x squared minus 5 bracket and times minus 3x to the power of minus 4 bracket. Yeah. And you could write as a fraction, but I don't mind if you leave this one. Well, why not? We're doing a little bit extra. X squared minus 5 squared times the inside bracket become to a fraction, so x to the power 4. And that's become to 60x to the negative 2 and minus 30x squared. So I move that one to the multiplies. And then actually is plus the 15. That's it. So in total, what we're gonna do, and we actually can leave this one as our questions. Yeah, that's it. If you leave that one, okay. Example 3. So now we got EX. If you remember, EX actually your y equal to, and then dy dx equal to e to the power x. So we learned this one previously. Okay, then how about u equal to EX, du dx equal to EX, and v equal to 2x squared plus 1, and dv dx equal to 4x. And dy dx equal to ex times 4x plus ex times 2x squared plus 1. And we both have ex, so we can rewrite dy dx equal to ex 4x plus 2x squared plus 1. That's it. Or you can rearrange a little bit, become to e to the x 2x squared plus 4x plus 1. They're both right, but just more accurate. Yeah. Next one. All right, more questions. Let's go with the sine graph. Okay. Now, let u equal to 2x squared, let equal to sine 2x, and du dx equal to 4x, and dv dx equal to 2 cos 2x. So dy dx equal to, just in case you don't know what happening here, if you have y equal to that, dy dx equal to k cos k theta. All right, now let's start with that. So u times dv dx and plus v times du dx. So that equal to 4x squared cos 2x plus 4x sine 2x. That's it. That's all we have today. Hopefully you learn how to do the product rule, which is like you have two different functions and you multiply each other and about their derivative and the plus. Okay, so hopefully you enjoy that. Questions you all can do. So question 1 to question, I forgot 13 or something, but yeah, all question you can do. Enjoy. I'll see you next time.